Oh, Mr. Schmidt.
We're back.
It was an awesome nap, wasn't
We're back.
it?
Yep.
Oh, I want pizza. Okay, so it's time for math. Well, you know what, guys? The good news is this is some fun math.
Yeah.
I really love it.
We're going to show you something cool.
Yeah, and Mr. Schmidt has some awesome stuff. It's not going to be boring. We're sick of boring. Okay, so you can multiply 3 numbers in any order task. Okay.
And this comes from illustrative mathematics.
Yeah, we know how to do that.
Yeah.
Okay. So make sure you have plenty of, well, we don't have snap cubes, but Mr. Schmidt has something awesome, and we are going to download it onto Google Classroom, Candy's class.
Well, we'll put the link.
Yeah, we're going to put it on there, and so you can bring it up, and you can do it, or you can do it here. So we'll make it work.
Yeah.
Okay, so build a rectangular prism that is 2 cubes high, 3 cubes wide, and 5 cubes long. We will say that the volume of 1 cube is 1 cubic unit. We know what that looks like, one of those little cubes. What is the volume of the rectangular prism? The volume
Yeah, and by the way, let's point that out.
Yeah, that's wrong. So
In the activity, they said the volume of the cube is 2 by 3 by 5.
Yeah.
And we know a cube has to have the same measurements on all sides.
Yeah,
So
somebody just made a boo-boo.
that was just a mistake, yeah.
Yeah, somebody made a boo-boo. We all do it,
Yeah.
so we'll let them slide
Yeah.
this one time. But the volume of the rectangular prism is 2 by 3 by 5 cubic units. The expression is 2 times 3 by 5. So what we're looking at is something that is 3 by 5, and then it's 2 high. So it can be interpreted as 2 groups with 3 by 5 cubes in each group. 3 by 5 can be interpreted as 3 groups with 5 cubes in each group. How can you see the rectangular prism as being made of 2 groups with, oh my gosh, Mr. Schmidt, I'm getting a headache.
Yeah.
Yeah, explain how you can see each of these products.
And we can show them the solution of how to visualize all that. But
Yeah.
let's show them want to show them how to build it?
Yeah, I just want to show them how to build this here, because that's like, ooh.
This is toytheater.com, and this is the math section where they have math manipulatives you guys can use. And so right now I have it clicked on this. That looks like a sniper scope or something.
Oh my gosh!
But that's how you adjust the movement of it, like how you're looking at it.
The rotation.
Yeah.
So maybe like a compass.
Right. And so if I click the plus sign, that's how I can add cubes. And when you actually open this, it would start with the plus sign. So, okay, tell me the measurements. We needed it 3 wide.
2 by 3.
2 high?
No, I'm sorry, 3 by 5.
3, okay. 3, there's 3 wide, okay.
Okay, and 5.
5 long.
5 long.
1, 2, so that's 3, 4, 5. 1, 2, 3. Okay, and so I added 4. There's 5 there. 2, 3, 4, 5.
Okay, so let's stop there. How many 1 centimeter blocks do we have on the bottom?
Let me go back to this so we can move it around.
Okay, so we have 3, 6, 9, 12. We have 15 on the bottom.
Ah, cool. The hammer erases them.
Yeah, I figured that. That was pretty cool.
Yeah.
I love it. I know the kids will love that.
Yeah.
A hammer.
Yeah.
Okay, so we have 1, 2, 3, 4, 5 by 3. 3 times 5 is 15. So that is the first row.
Okay.
Okay, can we change the colors, Mr. Schmidt?
We
Do
can.
You know?
We can.
Okay, let's make the top color a
Let me
different
see.
color.
Oh, and so I imagine I have to choose over here.
Okay, cool.
So,
cool.
Yeah, you ready?
Uh-huh.
Okay. So let's try it and see what happens.
Awesome.
You want me to fill the whole layer?
Yeah, let's go for it.
Kids are gonna like this. I hope you guys like it. I'm having fun doing it.
Yeah, this is pretty sweet. I love it.
And we can spin it around. It's cool.
Yeah, that's cool. So now you can see, well, if the bottom layer, the blue layer, was 15, and the red layer on top is exactly the same amount of space, that must be 15 as well.
Yeah.
What is 15 times 2, guys?
So that is 3 by 5, right? Each layer is 3 by 5, and then we have 2 layers, so it's 2 times the quantity of 3 times 5.
So the
And by the way, what property of multiplication is this?
Distributive.
No.
No.
Isn't it the associative property where it doesn't matter how you group them?
Yes,
Yeah.
yes. But I thought it was distributive if you did multiplication.
No, there's an associative property of multiplication.
Oh,
yeah.
Really? I didn't
Yeah,
realize.
in
I
fact,
thought it was
on the
distributive.
thumbnail for this video, I have it.
Oh, I thought it was distributive. Okay, I trust you.
This distributive property is where if I had this 2, I could say, well, that's the same. This 2 times the quantity of 3 times 5. I could say, well, that's also 2 times 3 and 2 times 5. That's distributive property.
Yeah, you're right.
Yeah.
You're right.
Where you
I'm
distribute
wrong.
the multiplication.
Okay, Mr. Schmidt.
Associative, I always tell my class, associative is like if these 2 friends hang out with each other, right? The 3 and the 5 are hanging out together, but here you can have the 5 and 3 can hang out together. They can associate with each other, right? And it doesn't matter how you associate them,
Oh,
right?
my goodness. You are absolutely right, Mr. Schmidt.
No, I'm...
Oh, no. You're absolutely right.
So I'm just
you
saying,
were
I always have
right.
I have kids go up in the front and we act it out, right? We hook elbows with these 2 and then we unhook and we hook elbows with the other 2. And so all it's saying is this is also very strongly related to the commutative property, right?
Yeah.
It doesn't matter what order you multiply them in, you'll get the same answer.
Yeah.
But now let's look at the solutions, right? Because they wanted them to represent this.
Yeah.
Well, they say explain how you can see each of these products by looking at the rectangular prism in different ways.
Yeah.
So we did this first one, right?
The first one.
We did this. Okay, and now let's go down. Here's a picture, right?
That's a picture of what we did.
We made that design, and we had the 2 layers, right? We had a red layer and a blue layer.
Yep.
Now they're saying, okay, you could also do it like this, where you have 6 groups of 5, right?
Yeah. Yeah.
Because that's 2 times 3, and then 5 of those. Okay, and then you could also have all these separate groups of 3, right? That looks like 10 groups of 3.
Yeah.
Okay, and then they have it this way, where they split it into
Oh, Mr. Schmidt,
3
I have a
tens.
headache.
No, don't get a headache.
Oh.
And then they even have it this way. So there's lots of different ways you could arrange it.
Yeah, I mean, if you have the cubes or you play with it, how many ways can you do this?
Right.
Yeah.
And you guys use that. It's toytheater.com. And you know what? I'll put a link to that cube activity because I don't know if you could easily find the cube activity.
Yeah.
You know, I found it by doing a Google search for the cubes. So
Yeah. So we'll put it on there and
Yeah.
make it easy for you
we'll put it in the
guys.
classroom and on the description for this video.
Yeah, let's make it easy.
Okay.
Okay.
Here's our problem.
Okay, so
And we thought this looked easy, and then we said, oh, there's a little bit of a
There's
thing.
a little bit of a little
Yeah.
glitch to
Yeah.
it. Okay, so we have $42.60 divided by 8. Well, you know, when we first look at it, we're like, oh, this is easy cheesy. Can't believe how easy. No. It does not go in evenly.
Right.
So if I was going to draw a picture, $42.60 divided by... That sounds like me and my kids. Except for I don't have 8 kids. Thank you. But $42.60, I have to divide it up amongst my kids, and it's not even, and so somebody's fussing about, well, I need more than everybody else. So you could figure out, well, how are you going to divide this up? Okay? How would you think that you should divide it up, Mr. Schmidt?
Well, you mean like the standard algorithm?
No, for the drawing a picture.
Drawing a picture of this.
Yeah.
Oh boy. I don't know. That's a good
It's
question.
not going to work out evenly, so
Yeah.
somebody is going to end up with a tiny bit more.
Yeah.
So
We'd have a remainder,
yeah,
I guess, right?
Yeah, so I
have a
would think
remainder.
that each person is going to get a certain amount.
And then we'd have a remainder
Oh,
outside.
shoot, shucks, and holy moly. Yeah, there's going to be a little bit of extra. So you could draw out 8 boxes, and so I'm saying boxes because you know what a horrible drawer I am.
Yeah, those could be capital G's or boxes.
You don't know what the heck they are. But so each person is going to get a certain amount of money, but there is going to be some extra. So I do want to model that for you because we haven't done that, and they were not really forthcoming with this. So it was kind of like a surprise. I did it twice because I'm like, did I do something wrong? Because it didn't work out evenly, and I didn't expect it to be that way. So I have $42.60, and I'm not going to put the dollar sign in there yet because I'm going to divide.
Yeah, and we know we're talking about dollars.
Yes. I will when I have my answer. I'm going to take my decimal straight up, so it's going to be right there. Okay, nice and big. So 8 goes into 42 because it doesn't go into 4, so I need to go over to 42. 8 goes into 42 5 times. So 5 times 8 is 40. And I am going to subtract, and that left me with 2. Remember, since I moved my decimal up, I'm ignoring this. And so I bring down the 6. And I like to bring my stuff down so I remember what I'm doing.
The divisor, you brought it down.
And so 8 goes into 26. It actually goes 3 times. 3 times 8 is 24. And so I'm going to subtract again. And I have 2 left over. And so now I'm going to bring down that 0. So how many times does 8 go into 20? Well, 8 goes into 20 2 times. 2 times 8 is 16. And I ended up with 4 left over. And, well, yeah, I know. It didn't work out evenly, and what are they doing to us? But we all know we're big people. We can add another 0. We know that. And so we can bring that down. We're going to bring down our 0. We're going to bring down our divisor. 8 goes into 40 5 times. 5 times 8 is 40, and it worked out. Now, you're saying, but Ms. Schmidt, we're talking about money. Well, we know that it didn't work out evenly, but how do we deal with this? Because we do not have tenths, hundredths, thousands of cents. So we need to round. Is the 5 big enough to change that to? Yes, it is. So we are going to change that to a 3 and get rid of that. So actually our answer, we are going to go ahead and round, and we're going to call that $5.33. And the reason I'm doing this instead of leaving it with 5 and 325 thousandths is because we are dealing with money. And we need to round in order for it to be money. But if we were talking about all of the 8 kids that I do not have, it would be each child would have ended up with $5.32, which they better have done a lot of house cleaning. Because, woo, I didn't give away money. You know me, I've got to buy shoes. And I've got some shoes to buy.
If you guys hear the heavy breathing in the background, that's our dog Maggie chewing on a bone, and she's loving it.
Yeah. Okay, so we had $5.32 for each of these folks. And that seems like a lot of money to be giving away. And then we ended up with that 5. Well, what was that? It was
a remainder 4.
Yeah.
So that's 4 cents. There'd be a remainder 4 cents.
Yeah.
What?
Okay.
It would be remainder 4
so
cents.
it would be a remainder of 4. Yeah, I was thinking about that 5. It was actually going to be tens, hundreds, so it was going to be 5 thousandths if we left it up there, wouldn't it?
You can't have 5 thousandths of pennies, right? This would be
5
pennies.
thousandths of a cent was what was left over.
It would be 4 over 8, which is half.
Okay.
So.
Okay. Right, whatever. Okay.
I'm just saying, if you worked out this problem, you were physically giving out money.
Yeah,
you'd have 4 cents.
We would have left over 4 cents.
So if I drew a picture, I'd have to draw the 4 cents.
So dividing by 8, it would have been.
You'd have 4 cents left over.
Oh, whatever. Okay.
You stop yourself.
Yeah, whatever. Okay.
You see how she treats me?
Okay, so there's 4 pennies left over. And so we cannot divide it up. We can't break up pennies, okay?
Right.
So
because you need to break them into half a cent, which is what that 5 would be. It'd be a half a cent.
But you're going into fractions, but we're not doing that right now. So, anywho, use another strategy. Mr. Schmidt has another strategy.
Oh, Lord, have mercy.
Okay, so I'm going to try and mastermind this strategy. But remember, if you get a
Let's
headache...
switch colors.
Okay.
I think we should switch colors.
Okay, because I am not feeling this. Okay.
She doesn't like my strategy.
Oh, I love it, but, oh, she's a meanies. Okay, so... we're going to work here, and we're going to say we're having 8, and I do know how to do this. 8 into...
And we drag this way down.
Yeah.
To keep it separated.
4 to 60 cents.
$42.60, yeah.
And we are going to make a... Ooh,
pull
that's
that
a
way
crazy
down.
line.
Yeah.
Okay.
And if you were in my class, you should already recognize this.
Okay, so 8 into... it's not going to go into 4,260...
Well, here's what we do. We look for multiples of 8. Easy multiples of 8.
Mm-hmm.
You could do 8 times 100. But I said, hey, I know that 8 times 500 would be 4,000.
Yes, definitely. 8 into 4,000 would be 500. And so it would be 4,000, correct?
Right.
Okay.
So usually I write this number over here first on the right.
So I'm going to write the
500. I'm showing how many
here.
8s did it take to give me that 4,000. It took
5.
500 8s.
Okay, 500 8s.
Yeah. So now we put a subtraction sign.
And then we're going to subtract, and
Yeah.
we have 260 left over. Okay,
So then I look at
still
260.
Going to,
Yeah, sure.
Oops, I'm sorry. 8. 8
And I
into
say, hey,
200
26. I know 24 is a multiple of 8.
That's going to be 3.
So 3 times 8 is 24, so I need to add another 0. So it'd be 30.
Yeah, 30. 8 times 30 would be 240.
240, yeah.
Okay, so 240.
It would take 38 to give me 240.
And so I have 20 left over.
And then we're saying, okay,
and so
2 8s.
8 into 20.
If I use 2 8s, I could get 16.
That's going to be 2.
Sure.
I'm sorry. That's going to be...
no, it's 2.
2, which would give me 16.
16 goes here. Yeah.
I'm sorry, I got off track. 16.
There's our remainder
and
of
then
4
the
again.
remainder of 4.
And now we
Okay.
just add up those
and
multiples.
So if we add all of that
Add
up,
those
then
up.
I've got it all over. So it's going to be 532. Okay?
Uh-huh.
With a remainder of 4. Okay.
And so we look at our decimals up there. So let's write that
let's
in.
say we're gonna
The 32
say
would be past the decimal.
it's
The
gonna be
5 would be before the
and
decimal.
32.
Yeah.
Okay?
And with a remainder
with
of 4.
that remainder of 4.
And 4 over 8 is the same thing as 0.5 or half, right?
Yeah.
So we would have a half a cent.
So let's go ahead and we'd make that into a fraction so that's 4 8s because we know that.
Yeah.
So
That's
4
the 4 extra
8s
pennies.
is 5. Okay.
Yeah.
So it's 5, and so that's how that worked out. So it's kind of crazy talk, but it's fun.
It's not crazy
it's
talk.
Kind of
You Eisler kids, you better remember how we did that.
Yeah,
This is cool because you get to choose how you subtract things because
Yes,
really division is repeated subtraction.
Yeah.
Multiplication is repeated addition and division is repeated subtraction, and you get to choose how much you subtract at a time.
You know what? Chavez kids know how to do this. We're just above it.
Okay.
We're kidding.
I don't know what Chavez
kidding.
kids know.
Yeah.
I know you guys
yeah.
are smart.
Yeah. Oh, we're all smart.
Yeah.
We're all smart. But yeah, this is kind of cool.
That's just another way to do it.
I don't think I've used it in a couple of years, but I do appreciate Mr. Schmidt because he reminds me of things that I haven't done in a while. So I definitely have a little cobwebs when it came to that. But,
I like that way because
yeah.
it gives you
it's a fun way.
it gives you autonomy where you can
Yes.
choose how you do it.
Yeah, it's a fun way to do it.
Yeah.
Okay, so write a word problem. Make for sure that you go ahead and do that in there. So what could you do?
Well, you already talked about kids
I
sharing
talked
money.
about my kids sharing money. Okay,
Yeah.
so we had 4 pennies that we put in a piggy
Yeah.
bank for another day or something.
Yeah.
Okay, so let's
Reteach.
go ahead and
Lesson
take
12.
a peek at this. Okay, that is Maggie getting a drink of water.
Well, she just finished the big bone.
Yeah. So, let's take a peek at what we're looking at. It says problem solving, make a model. Nick is helping the local charity fill boxes with cans of food. He has already put in 1 layer of cans. To fill up 1 layer, it takes 16 cans of food. I am so glad because my piece of paper does not look like that. 16 cans of food. If the box is filled with 3 layers of cans, how many cans would be in the box?
Can I just say that if you had 3 layers of cans in there, they don't look like they would fit.
No,
that looks like it'd fit
like
2 layers.
Definitely
That box is
2.
not tall enough to fit 3 layers.
I'm thinking, okay, so let's just deal with it. I agree with you. So there's 16 on the bottom. So 1, 2, 3, 4, because I don't believe it either. 4, 1, 2, 3, 4. So there's 16 here. And so another layer would be 16, and then another layer would be 16, right?
Mm-hmm.
Okay.
Right.
So basically that's what they're looking at. And everybody that knows me knows how much I hate these little sentence frames. So
why do you hate the sentence
I don't
frames?
know. I do, because I work ahead of them, and then I have to go back and fill them in, and I'm like, ah. But it's cool.
Well,
Okay,
I know
it
that
keeps everybody kind of straight.
professional development, they always want us to do
I
sentence frames.
know. That's how come
Yeah.
Okay, but it's okay. What facts do you know? There is blank layers in the box, so there are 3 layers in the box.
No.
And already.
See,
I'm
that
so
doesn't
sorry.
make sense.
See, that's why
Bad
I
grammar.
hate it.
Bad
That's
grammar.
why I hate it. I hate it.
There was
I hate
one
it.
layer, right?
Oh my goodness.
Layer is singular.
Ah, jeez.
So they gave it away to you guys.
Killing me. There is blank layer.
One layer.
In the box. Yeah, it did say 1 layer in the box already. There is 1 layer.
And you know what, guys? On her paper, she already had it written down.
Yes,
1 layer.
I know.
She's getting tired.
Yeah, 1 layer in the box already. There are blank cans in each layer. So we know that there are 16 cans in each layer. What do you need to find the number of cans in the box when there are 3 layers? Okay. You can solve the problem by making a model. Okay, I can see that. Okay. Arrange blank cubes in a 4x4 array.
Well, we've already said it, right? And they love to repeat things.
Arrange.
How many cubes do we need, guys?
16 cubes in a 4x4 array.
Yeah, just say what's 4 times 4. Well,
that's how come I hate them, because it just is like repeating. Okay, stack the cubes until there are how many layers, everybody?
3 layers.
3 layers.
This is my math. They repeat things several times.
I know.
Yeah.
It's how come we don't use it? Okay.
We use it sometimes.
Yeah, sometimes. Okay, there are a total of blank cubes. How many cubes are there altogether, Mr. Schmidt?
Okay.
There are, well, if I have 16 and 16 and 16, okay, so that's an 8 and carry the 1, it's 48. Okay, so there are 48 cubes. So the box would have 48 cans. Okay?
And 1 layer would be sticking out of the box.
I know, because that box isn't big enough.
That box
for
is too
3
short.
I'm sorry, it's not going to happen. Okay. That's just crazy talk.
They should have used tuna fish
Crazy
cans.
talks. Yeah,
Shorter
yeah,
cans.
something. Yeah, that's like that book from yesterday.
Is my answer reasonable? Explain.
Well, it isn't, because
There
there's
are
not going to be 3
3
layers.
layers.
Yeah. Okay. There are 3 layers, and each layer has
16 cubes.
16 cubes.
So,
So the total number of cubes is
3 times 16.
3 times 16
Or
or 48.
cool.
Okay.
All right. And
Cheesy
then you can see
easy.
here, we had all the right answers. And now here are the word problems.
Okay.
And some of these are juicy.
Yeah. Oh my goodness.
When I say juicy, I mean like, well, there's meat to it. You know?
Yeah, making Mrs. Schmidt's head hurt.
Yeah.
Okay.
Can I read this one?
Yes, you may.
Hugh is making a block tower. Each block is a 4-inch square and is 1 inch thick. If he has 35 blocks, what is the tallest tower he can build with the blocks?
Okay. So, what I'm going to say to you is this. Nonsense. Okay, so this is 4 inches, and it is 35 high. Correct?
Correct.
Okay. So I'm not going to possibly build 35 blocks high, but this is what we're looking at. And you can see my blocks are getting
on the
crazy.
screen you're not, right?
Oh, heavens no.
But if this person, if you did that.
Yeah, you could. Crazy talk, who'd do that?
Take some serious balancing.
Yeah, seriously. So what I'm looking at is I'm looking at my 4-inch blocks times 35 because it's 35.
So we'd be setting them on
high.
End, right?
Yeah. So 4 times 35. So I'm going to come up here and I'm going to say 35 times 4. And 4 times 5 is 20. Carry my 2. 4 times 3 is 12. Plus 2 more is 14. So I have 140. Now, I have 140, and it is in inches, so I'm going to put inches.
And that's how tall it can
And
be.
that is just how tall it is.
That's the tallest we could make those blocks.
It's single. We're only measuring one side here, so that's
You're
what
standing
it is.
them up with the tall edge facing upwards.
140 inches. Okay.
Okay. The next one was juicy.
Oh, yes.
Sarita wants to organize her bookshelf in her bedroom. The bookshelf measures 36 inches long, and there are 3 shelves. If she has 25 2-inch wide books, 15 3-inch wide books, and 32 1-inch wide books, will she be able to fit them on the 3 shelves? If not, how many of each book will not fit?
Fit on them on the 3
That's a juicy
shelves.
problem if I ever saw one.
Oh, it is. It is.
Yeah.
Because it's kind of crazy talk,
There's
guys.
lots of details in there.
So, what I want to do first of all is I want to count my books. So I have 25 2-inch books. So I'm going to say 25 times 2, which is going to equal 50 inches. Okay. And then I have 15 3-inch books. So I'm going to say 15 times 3-inch, which is going to be 45 inches. Okay. And then I have 32 1-inch books, which is going to equal 32 inches. Okay. So I want to, first of all, I want to see, well, how much do I have in books? How many inches do I have? So I'm going to add these babies up first. So I'm going to say I have 5, 6, 7, and then I have 9, 10, 11, 12.
So it's 127.
It's 127. Thank you.
All the books stacked up together side by side.
If I did it, I have
would
127.
require 127 inches.
But I have 3 shelves
that are each
going to be
36 inches long.
inches. So I have 36, 36, and 36. So how much do I have there? So I'm going to add those up, and that's 3 times
18.
That's 18, and that's 9 plus 1 is 10, so I have 108.
So we have 108. Let's put inches.
Yeah,
Let's put inches
definitely.
there.
So I definitely have way too many books.
We have
But
more
subtract.
book width than we
I'm
do
going
shelf
to definitely.
space.
I'm going to subtract and find out how many books have to come out.
Or what the width
yeah,
would be,
what the width is going to be. So I need to regroup. So I'm going to make that a 1, and I'm going to make this a 17. 17 minus 8 is going to be 9. And then 1 minus 0. What did I do?
Nothing.
So 1 minus 0 is 1, right?
That is correct.
Okay. So I have 19 inches. I have no idea what I said. So I have
Didn't say anything.
19.
I'm just having, my class knows what's going on.
Okay. So I have 19 inches left over.
I'm just having fun.
Okay. So I am short 19 inches. So I need to take out minus 19 inches
Of books.
of books. So no, she is not able to put all of the books on the shelf. Okay. And so, what can we take out? So,
Well, immediately we say, okay, some of the books are 2 inches wide, correct?
yeah.
So we could take
definitely.
out.
Yeah, so I'm going to take out, so I'm going to say I can take out 9 books that are 2 inches, and that would equal 18 inches, okay?
Now
and
we
then
have 1
I need
inch
to
left,
take
right?
out one 1-inch book, which would equal 1 inch, okay? And so 1 plus the 18 equals the 19 inches. Okay.
How many of each book will not fit? So 9 2-inch books will not fit, and 1 1-inch book will not fit.
So no, she did not have enough space, and we were able to take out this amount here, and so we're in good shape. Okay. Does that make sense, Mr. Schmidt?
That makes sense. I mean, I could see. What if you used the 3-inch books and you took those out?
Yeah, you could.
6 times 3 would be 18.
You could take out the. You could take out 3
So
of.
there's different ways you can do it.
Yeah.
As long as you took out 19 inches worth of books, but you'd have to make sure that all the books fit on the 36-inch shelves.
Yeah, there's a number of ways that you could take it out.
Yeah.
This is just how I chose to do it.
Yeah,
but
sure.
there are definitely other ways.
Okay.
Okay?
Let's read number 3.
Okay.
Phyllis is making a clay game board. Each square needs to be 2 inches by 2 inches. If the board will be a 16-inch by 16-inch square, how many total squares will it have? That seems easy peasy lemon squeezy if you could just draw it. I mean, you could draw that.
Yeah, definitely. So I'm thinking, well, if it's 16 inches across,
and each one is 2 inches long
16 inches
or wide.
this way, 16, and each
You guys,
one
I know
is
that doesn't look even, does it?
Oh, you hush your breath.
That looks like a rectangle, not
I
a
know.
square.
And so,
Should look like a square.
and each one of them is 2. So 2, 4, 6, 8, 10, 12, 14, and then 16. I'm getting really, because I don't want to run over.
Yeah.
And then going down, 2, 4, 6, 8,
Just keep going down.
10, 12, 14, 16. And we could definitely fill them all in, guys, but we're not going to do that because we do know our multiplication, and how we can do that is we can say...
We need to say how many squares go across the top, how many go along the side.
Yep. So I have
It's
1,
an 8 by
2,
8.
3, 4, 5, 6, 7, 8. So I'm looking at 8 this way and 8 this way. 1, 2, 3, 4, 5, 6, 7, 8.
And you guys know what 8 times 8 is?
8 times 8. So you should be able to figure out how many square inches.
Wait. That's a different problem.
Oh, I'm sorry.
We're up here. Yeah.
Okay, I'm sorry. We moved down. So square inches.
Well, they're not asking square inches, though. They're asking how many total squares will they need.
Oh, I'm sorry. So how many will you need? So how
Yeah.
many 2-inch squares will you need? So, you can figure out what is 8 times 8.
8 times 8.
And there you have your answer. Okay? We can let
Let's
you
go
do
down.
that.
Paxton has a sheet of stickers that is 11 inches long. Each sticker is a 1-inch circle, and there are 10 stickers in each row. How many stickers are there on one page?
All right, Mr. Schmidt, what's your plan here?
Well, if the whole thing's 11 inches long and each one's a 1-inch circle, that seems pretty easy to me. There are 10 in each row. It's 11 inches long.
Mm-hmm.
I mean, as long as they don't say that if there's a space between the stickers or not. So I'm
No.
going to have to believe that they're touching each other.
Yeah, so
it looks like 10 times
if
11.
we have 10 across and the whole thing is 11 long, so we have 11 rows of 10.
Yeah.
Whoops, I'm sorry. 11 rows of 10. So what is 11 times 10.
Well, we know multiplying times 10 is super easy.
Yeah, so I think you guys can handle that
Sure.
one again. So that would tell us how many
Okay,
stickers.
and I don't want to scroll down because then I think we're going into the answers down there. Yeah.
Yeah, we
Okay,
don't want to do that.
so number 5, Cindy is making a picture frame with shell. Oh my goodness, the shell.
Yeah, yeah.
So, okay, let me start again. Cindy is making a picture frame with shells she found. Each shell is 2 inches long. Isn't that convenient that she found these shells and they all measure the
2
same
inches
amount?
long.
If she makes a rectangular frame out of 20 shells, how large can she make the frame?
Yeah, we spent some time contemplating this.
Well,
so,
sure. But especially since the book gave us a weird answer.
Yeah, so it's 2 inches long. It does not tell us how wide it is. It could be this long. I mean, we have no idea what's going on here.
We know
But
we
we're
need to
just
use
going
the
to
2
work with
inches,
this.
right? 20.
So,
yeah.
what we're going to do is we're going to come over here and we're going to go like this. It's a rectangle. We know that. And so if they're 2 inches, so I'm going to go down like this here. I'm going to say 2, 4, 6, 8, and 10. Okay, so each one of these is a 2. Okay, yeah, my 2s are getting ugly, guys. I'm sorry. So each one of these are 2.
How about if we read it 10 off to the side?
Yeah, that's definitely 10.
Yeah.
Okay, so we're going to do the same thing over here. 2,
Wow, that's a big one.
4, 6, 8, and 10. Okay, so it's against 2, 4, 6, 8, and 10. Okay? Okay.
And we're talking inches, so those are 10 inches
so
and
we
10
have 1,
inches.
2, 3, 4, 5. So we've used 10 shells so far. So now we need to use 10 more. Okay? I'm sorry, that's, we've used how many shells? 10? And so we need to use 10
We have
more.
20 shells, so we need,
Yeah, so we are going to do 1, 2, 3, 4, 5. Okay, so we're going to go 1, 2, 3, 4, 5.
But imagine those are lengthwise.
Yeah. And then we're going to go 1, 2, 3, 4, and 5. So each one of these are 2. Okay. And so we have, this is 10, and then this is 1, 2, 3, 4, 5, 6, 7 across.
7 times 2 is?
Yes. It's going to be 14.
And so we're imagining that the width is the same as the length.
Mm-hmm.
I mean, the shell has to have some kind of measurement across.
Yeah. Yeah.
So are you going to write a 14 up there?
Yeah. So what we came up with
And a 14
was,
down here, babe?
yeah, 14 here. So what we came up with was 10 by 14.
Okay.
Okay. This one is a really not good problem.
Yeah, the book, man, their answer was...
Yeah.
They only used... To get the answer they used, we would have only used 10 shells. So...
Yeah.
So...
Because if you look here, we have 2, 4, 6, 8, 10, 12, 14. So this is how we got 14. It's not 14 shells across, guys. It's 2, 4, 6, 8, 10, 12, 14 shells.
No, not 14 shells.
No, I'm sorry.
14
inches.
Yeah.
2, 4, 6, 8, 10, 12, 14 across.
14 inches again.
14 inches. So that's, it doesn't, yeah, it's me, guys. Seriously.
No, it's also the book.
Yeah, but it should look more like this here. If this is 14 and this is 14, 14 should definitely take up more space than 10, right?
Okay.
Yeah. So, anyway. So, it's 10 by 14 is what we came up with.
10 by 14 inches?
Yeah.
10 inches by 14 inches?
Yeah, that's what we were able to get. So,
Yeah.
anyway, it was an ugly problem. We fought over it. Mr. Schmidt lost some hair because I pulled it out.
Oh.
But then,
At my
you
age,
know,
I can't afford to lose some hair.
but you know what? He tackled me to the ground and made me
No,
say,
I did not. Maggie would have bit me if I did
yeah,
that.
she really would have. But anyway, she wouldn't bite him.
If
So
I
anyway,
tackled you, she would. She'd be upset.
She might tell you to get off my mama.
Yeah.
Anyway, so anyway, guys, that was a tough problem. So
And this video is already 40 minutes
do
long.
your best.
Yeah.
So it has been a great day. Enjoy the rest of your day, and be kind to your parents. And we will talk to you later.
Take care of yourself. Stay healthy.
Bye.
Bye, guys.